Come on. There we go. All right, so on your graph page, yours will look different. Your graph paper is different, so therefore your graph will look a little different. So if you notice, mine is like I skip grid lines in between. Wow, what is wrong with that?
What is that?
Hold on, I gotta fix something real quick. Let's see. Wait, what in the world? I don't know. Oh, I know. There we go. There we go. Probably. But there's no more warnings now, so. You got phones out. There's no more warnings coming. I see a phone, you're up on the list.
Is it a specific person or the entire class?
I don't know. I don't see anybody because I'm looking this way, but sounds like somebody's got a phone out.
No, people are just pulling out food.
It almost went down my.
And there shouldn't be any food out, no drinks out. Let's just deal with all that at once. Shouldn't see anything out except for you guys with notes ready to take notes. So you need to write down on your graph. You need to copy that table and that equation. Again, I'm doing the bell work for you. I'll zoom in a little bit. I can't zoom in a whole hell. Make a lot. It'll be larger. Settle down. You don't need to write the graph. You got the graph. There. I'll scroll down in a little while, but that should be large enough for you to write everything you need there.
Wait, Mr. Gill. Is it this?
Oh yeah, and you're only using the upper right quadrant. It's all positive numbers. Like so, this is what you have. I'm only using this section and when you look at my graph.
Wait, do you write the graph on here? Or like in our notebook?
Graph?
Or not the graph?
Write it wherever you want.
That thing.
As long as you
Table
got
thing.
it. It's your notes. You're the one who uses them. So if you want it on graph paper, write it on graph paper. If you want it in a notebook, write it on a notebook. But they're going to go together. So you need to, if it's in your notebook, you got to be able to match it up with the graph paper. So the equation is f of x equals 2x plus 1. I'm going to go through all these reminders, but just remember, this is the same thing as just saying y. Y equals 2x plus 1. It's just the answer, the output, what we get when we do the math on the right. Same thing. So, quick reminder. I'll give you another minute or so, and then you should be done. So we're moving, all right, I'm just gonna write it here. This is our new topic. It's on the first page, but I'm doing the bell work for you. That's mine. So that is our topic, exponential functions. We did functions before, but we did linear functions. So in this lesson, there are going to be some really easy things and then some things that are a little tougher. But like I said, when I build a quiz, I'm going to build in, like, for exit tickets, I normally build in like 50% easy stuff as opposed to 30. So I'm going to give you a lot of potential easy questions today, and then we'll start getting into a little bit of the harder stuff today. Mainly some of the harder stuff will be next period. So make sure you're taking good notes today because there's going to be a lot of easy stuff built in. And I'm going to get rid of a lot of this, so when I write something down, you better write it as soon as I write it. It's not going to be up there for long. Too many of you wait and wait and wait, and then finally write it later. That's not going to work today. You can go back and watch the recording if that happens, which you know you probably won't do, so I'd write it down immediately.
Are you recording?
I was just gonna say,
Yep,
if you
should
start
be.
the recording, it's entirely.
Should be, yeah. Yeah, I always try to record you guys unless I'm having internet issues, which sometimes I have been in your class for some reason. All right, so exponential functions. You didn't get it? You can watch the recording. So when we talked about linear equations, we used this whole y equals mx plus b.
Yeah.
And we said in that formula, we have a y-intercept, and we're going to talk more about that later. And then we have a slope, or we also said rate of change. So you may want to write slope equals rate of change if you don't remember that. But the slope also equaled the rise over the run. And that's how we graphed, was using the rise over the run. So I'm just going to graph this one for you. So right now I'm graphing this. We're coming back to the table in a minute. So right now I'm graphing this, f of x equals 2x plus 1. Again, just y equals mx plus b. Same thing. I should see, who should see. Remember that in a minute. So my starting value is always the y-intercept, because I know where that's going to go. It's going to go on the y-axis. That's where the line is going to cross the y-axis. So I know there's a point there. It's positive 1 in this case. So I put a point on positive 1 on the y-axis. Here's my first point. For my next point, that's when we did the whole rise over run thing. We changed the slope to a fraction. And this is all review, so I'm going quickly. So my run is positive 1. And then my rise is positive 2. So there's my second point, right there. Now, in order to make a straighter line, don't graph anything. Well, I guess you can graph this one. That's fine. I don't want you to graph the next one as I do it. So as I do this, I could try to draw a straight line from just the 2 points. I'm going to put more points on there, and I do that by just following the pattern. I just go over 1, up 2, over 1, up 2, and I just keep that going. Here's one quick thing. If you don't understand this, it doesn't really matter too much. If you'll notice, my squares are not going up by 1. I'm kind of skipping 5 squares equals 1 so that you can see it sort of blown up a little bit. So I go up 1, 2, 3, 4, 5 squares is 1. 1, 2, 3, 4, 5 squares is then 2, and then I do the same thing on the x-axis. So some people ask me, well, how do you know? Do I go over 1 square and up 2? Or do I go all the way over 1 and then up 2, like using the big numbers?
Yeah.
Doesn't matter. Watch. If I did this, let's say I started here and I went over 1, like all the way to the big number 1, and then from 1 I go up to 3, the big number 3, I'd be right there, right? Because I went over all the way to 1, that's over 1, and then up 2 would be right there. If I just keep doing this pattern, I still land on the same spot. It doesn't matter. So don't worry about that. It'll work itself out. It does, as long as you're going over 1 and up 2, regardless of what the units are, you'll get to the same spot. Joe, it's not your seat. Over here. I mean, it doesn't take long. Like, you can't last more than 5 minutes. I don't know why you would try. All right, so I'm going to do my best to draw a straight line. This is a dead straight line, even though it doesn't look like it. All right, so that is a straight line. As straight as I can draw it freehand. Now let's plot these other points. This one I'm going to have to zoom out for. That's why I say don't do anything yet on the second line. I think it'll work with that. Yeah, that works. So and this is why I'm doing it for you, because I thought this was going to be much easier than it was. If you have a table and you have an x of 2, a y of 4, that's the same thing as saying 2, 4. It's just a coordinate, an ordered pair, a coordinate, a point. So I need to plot each one of these ordered pairs from the table. That's fine. We don't really, actually we do use that. All right. So now I'm going to do this again. Hold off for right now. Don't do anything just yet, because I want you to see the end result before you start plotting. I'll give you time. My x value is 2. My y is 4. How do I plot that point? What do I do first? Which way do I go first when I'm plotting points? X is 2, y is 4. Which way do I go to see Miss Graph first? Remember?
Oh.
You may not have been here tonight.
I think elevator thing.
Elevator thing. Which way do I go? I had to go, well, left or right first, depending on where she lived at the time. So I either go left or right first. Well, in this one, the 2 is here, so I'm going to go right. Then I got on the elevator and I went up and down. So I go right first to 2, then take the elevator all the way up. There's my, again, you're not doing this yet. There's my first point based on the 2 and the 4. Now I just keep doing the same thing. So based on the 1 and the 2, go to the elevator to the right one. I go up to the second floor or whatever you want to call it. There's my second point. Now it starts to get a little tricky, and this is why I'm having you just watch. You're going to get into decimals. And your squares don't go by like individual sections, so you're really going to get dots closer and closer together. So just when you do it, you got to do your best. You'll see what it looks like, so you can just kind of recreate that. So now if I'm at 1/2 on the x, that's right here, and then 1.4 would be right here. So that would be 1.4 for me. 1/4 or 0.25 would be right here, and I need to go to 1.2, which would be right about there. And then 0.1 and 1 would be right about here. And then 1 would be right there. So I'm going to try to draw this in the best I can. Oh boy, I messed it up there. So I kind of made it too thick in the middle, but is that a straight line? Absolutely not, because if it was a straight line, I would have gone straight from this point to that point, which I do not. So here's the first thing you need to write down. You're going to have to know how to do 3 easy things, as well as some other stuff, but here are the easy things. First one, probably the easiest, from a graph. If I give you either 1 line or 2 lines, don't know which way it'll be yet, you need to tell me, does that line represent a linear function, or is it an exponential function? For a new lesson. If it's a linear, how would we know if it's linear? Yes.
Straight.
Yeah, straight line. If it's a straight line, it is a linear function. So that's your first thing you write down. If you see a straight line on a graph, it is a linear function. And all we've done so far has been straight lines. We haven't graphed any curved lines, because all we've done is linear functions.
How do you spell the other one? Wait.
Linear is L-I-N-E-A-R.
Not that one.
Exponential, you should have wrote down a minute ago.
Oh, I got it anyway.
Yeah. And it's probably on that sheet too. Yeah, does it say exponential on the top of that sheet?
It's on.
Yeah, exponential, it's in the first section. It says exponential. So you need to know that one. So a straight line is a linear, L-I-N-E-A-R, linear function. So the red line would be linear. I'll write it, I guess, up here.
And then the blue one obviously is different.
So now obviously if it's not straight, if it's a curved line, it is an exponential function. So again, that's what I consider to be the easy 30% on, actually on an exit ticket, there's normally an easy 50%. Oh, quizzes. I'm not done grading them. I don't even think I've gotten to this class at all yet. Quiz grades have been pretty low. But again, I expected them to be low. It was a big quiz. There was a lot more on it than an exit ticket.
Do you remember mine?
I haven't graded this class. I just said.
Stinky.
So that's the first piece. How do I determine from a graph whether or not I have a linear function or an exponential function? And again, just straight versus curve. Pretty simple. Any questions on that? So what's the line you have on your paper? Exponential or linear?
Oh,
Exponential.
Exponential. It is a curved line, obviously very curved. Now that's not the question on that. Don't think it's that simple. You have to be able to create an equation for a curved line, just like we used to create equations for linear.
Be able to know if it's
line.
exponential or linear.
So we'll get to that next class. We're not going to get to that today.
I think we should. Sounds fun.
Well, trust me, we got a lot to go over. I think I already said it, but any questions on that? And we're going to come back to some of it. So here's your next thing.
So basically just like
Actually, here, let me show you one thing real quick. So here's the same graph. It's the same graph, only I've added in some negative numbers for x. If you'll notice when x goes negative, so here was the part we graphed right here. That's all we graphed on the other one was the positive part. If x goes negative though, we can still have negative values. If you'll notice y never goes negative, that can happen. So don't think just because my x values are negative, my y values have to go into the negative also. They don't. I'm not going to do the explanation I did in the other classes because I think it just confused people more. Just remember, these values don't mean y is going to be negative. You have to do the math and determine what would y equal. You have to plug them into the equation and say what would y equal. And that doesn't mean y is going to be negative. The fact that it approaches 0 and never gets there is called a limit. I'm not going to make a big deal out of that in this class. You'll see that next year quite a bit, that limit. So now let's go. All right, so here's two tables. I want you to write these tables down, kind of the way I did, one on the right, one on the left. Leave a little space in between each of them and to the right of this one because you're going to use this space over here. So leave a little space to the left, to the right, and in between. And I'll do some of it, and you'll help me do some of it. When you're done writing, just put your pencil down. I know you're. Don't doodle or anything. That's how we're done. I am going to probably move on since I'm recording this. If you haven't written it down, if you've zoned out, and you like Aaron who hasn't done anything yet, I'm going to move on. So you'll have to go back and get it from somebody or watch the video. What? What? Just copy. Didn't apply to you. I don't care. Alright, I think people are wrapping up, so I'm going to go ahead and do the next piece. Keep copying if you're copying. So if you'll notice, in both the tables, my x values are going up by 1. Really, the x values are the exact same in both tables. So now let's look at the one on the right. What's my pattern in this table on the right? So this one over here.
By 5s.
So what's the math that I'm doing? When you say going up by 5, I'm doing what? I'm adding 5, right? Pretty simple to figure out, not too bad. So we are adding, if you want to write adding, that's not a bad idea. I'm just going to do plus 5. What's my pattern on the left? Or is there one?
I don't want to know.
Plus 1.
It goes by fives.
The y values on the table on the left. Is it?
Yeah, because it goes 10, 20, 40.
No. It doesn't have a.
You're
It
saying
doesn't,
quiet, nobody hears you.
it doesn't have anything. It doesn't have an actual pattern.
Oh, there's a pattern. Yeah. it is. I didn't say the pattern had to be based on addition.
It goes 5, 10, then 20.
So what's the pattern?
20? Oh, no.
There is a pattern.
Because
Times 2.
Oh.
Somebody had said it several times, and she's just very quiet. Nobody heard her.
Bro, she stayed doing that. She don't have the answers, and everybody's like leaving them out.
I know. I'd listen to her more often if I were you.
I always do.
There. Yeah, you said pretty close. So there is a pattern, but it's based on multiplication, not addition now. Now, there has to be a pattern throughout the whole entire table for both of them. If all of a sudden I added a number over here, and let's say it was 4 and then 24. And so now I added 4 instead of 5. Immediately, if the pattern is broken, then there's no relationship at all. There's no exponential or linear. So when I'm talking about these, we're assuming that the pattern happens all the way down through the table. So again, if it doesn't, then there's no relationship at all. So just remember, when I'm saying this, I'm assuming we've already gone through and figured out that the pattern continues forever. There's no break in the pattern. There's no different answer that we would get. So here's your next easy quiz question. If the pattern in the y values, so again, only for the y values, x's will always be based on addition. You're never going to have x's based on multiplication. So this is just for the y values. If the pattern in the y values, I'm not going to write this because I don't have a whole lot of room, so write this. If the pattern in the y values, or y numbers, if you want to write y numbers, and yes, I'm going to say it again. Oh, that's one more column. My column never made it.
Okay, the pattern in y values.
So if the pattern in the y values is based on addition, so is based on addition, or adding, you just want to write adding, one word.
No. Let me get the rest.
If the pattern in the y values is based on addition, then what?
It's the same for it.
Yeah. Nobody can tell, nobody can read my mind. And everybody, I know this is an old show, but I've been binge watching. Anybody ever heard of Heroes? No.
Is that like the old show?
It is. Well, I mean, it's not like you were probably 7 or 8 when it was out. Well, maybe, actually, you may have been younger than that. It had several seasons, so you were probably 7 or 8 when it was in its last few seasons. That. It's based on addition, it's a linear function.
It's like a cheat answer.
Well, again, I told you there are going to be some easy quiz questions that come out of today. We'll get into some stuff that starts to get a little bit harder, but definitely today's the easier day.
It's a Monday anyway, thanks.
And that's why I do it. Well, plus it's just the first day we're introducing. Did you want any of this, or did you get some of the sheets earlier?
I got it.
Oh, you did?
Yeah, I got it, thank you.
Bro.
All right, so guess what we're going to say over on this table then?
That's gonna be exponential.
So what's our first part though?
And the pattern in the y values? Or probably, is it still gonna be, yeah, in the x values?
No.
It's still being
X
y?
values will always be based on addition.
So
That'll never
y
change.
in in the pattern in the y values.
So if the pattern in the y values, so you start the same way.
But it's still addition on this side.
Nope, that's why we're talking about the y values.
Oh.
Yeah.
We're not worried about x values.
Okay.
I just told you, x values are always going to be based on addition, no matter what the table.
It is based on multiplication.
If the pattern in the y values is based on, but now you just change addition to multiplication. Or multiplying, if you want to write multiplying, either way. So if the pattern is based on multiplying pattern in the y values, you do need to make sure you write pattern in the y values, just so you don't ever get confused about the fact that the x's are adding 1 every time in both tables. It's always based on the y values. Then it is an exponential.
Will there ever be a time when x is just like, you know, just add or
What in the world?
multiply?
That is weird. Look at that. It won't write. Huh. It won't write? No. Oh, I know why. I know why. Huh. Let's see this. I guess we'll have to write it up here. So that's supposed to be exponential. It's not letting me write the p in, though. Because I'm assuming there's something blocking that spot. Like there's an image there that I don't know what it is. Let me see if I can do this. So if the pattern in the y values, or maybe not. Yep. Yeah, I can't fix it. So if the pattern in the y values is based on multiplication, then it is an exponential function. So we've already learned how to pick them out from a graph, right? Straight curve. Now we've learned how to pick it out from a table. Neither of them particularly difficult, right? And you figure out what the pattern is. If it's based on addition. If there's no pattern, like if it ever breaks, then it's neither. If there's a pattern of addition all the way down, it's linear. Pattern of multiplication all the way down, it's exponential. So those two are not that bad. And those would be what I would consider the easy 30 or 50% or whatever it would be, depending on what type of quiz it is. Any questions? All right. Now let's get into the next one that we have to know. Oh no, it's actually on this. I'm going to get rid of this. Is anybody still writing? Delete everything that's up there.
So the exponential.
Actually, I don't really. I'm not going to. Never mind. I'm not going
The
to.
exponential one's on the left.
Well, which one's based on multiplication?
Did we say that one?
The y values. Which one am I saying I'm multiplying by something versus just adding something? Which table? On the left, right? Because I say right here. That's what this means. I'm multiplying by 2 every time. Here I'm adding 5 every time.
Okay, I get it.
Right.
I was getting confused because I thought the right one was exponential.
Yeah, you can't look at the x values. You may want to write that note, because remember, you guys write the notes down. I just told you this stuff. I just explained it. When you come back and look at this, whether it be in 2 days or 4 days or maybe 7 days if the quiz is next week, the exit ticket, you may not remember that as well. So if you need to write down, don't look at the x values. Like don't look at the change in the x values, or don't look at the pattern in the x values. Like write down an additional note so that you don't do something sometimes also. All right, so.
Why wouldn't you do that? Because that's not how you figure it out. Never mind.
I'm just saying write down whatever you need. Because I see it all too often that you guys don't, well, hopefully you have the notes. Some of you don't even have them. But you have them, but then you don't understand what they mean. That's not doing you a whole lot of good. So you need to write sometimes more than what I write, so that you can understand what it is that you have written down. So now, here's what we're going to do. We're going to create equations from both tables. I guess I can write inside the table real quick. So we know that one's linear. We know that one is exponential. So we're going to create formulas based on the 2 different types of equations. This is linear, because it's just the y equals mx plus b. Actually, if you didn't write those formulas, I guess I should make you write those down. I don't know if you did or not, but if you didn't write those two down. Hang in there for a second. I had a different plan, but it didn't go like I was expecting in the other class, so I'm doing more talking than I really wanted to in a row. I mean, you're doing some stuff, but you're more copying and not really doing any work on your own. Like I said, trying to have them do it on their own didn't go very well in the first class, so I changed.
I feel like you're gonna give us like some problems after this.
Well, that's what your worksheet is, but I wanted to break it up where I did some stuff and then you did some stuff, but when I had them try to do it, they couldn't do it. So that's why I'm going to do more. Like the bell work is an example. They had trouble just doing the bell work. All right, so this first equation, this is a linear equation. So here's your next easy note. The way you tell from just an equation. So let's say I don't give you a graph, I don't give you a table, I just give you an equation. If there, and I'm going to say something and then correct it, so just pay attention before you write down. If you don't see any exponents, right, that's a linear equation. Now, technically, there are exponents in it, because remember, everything has a 1. If that was a y, which it's the same thing as y, f of x is the same thing as y. Same thing as the variable y. That would be y to the first. So if you do not see any exponents, meaning all the exponents are really 1, that is a linear equation. So then what would the other equation, what would we say to describe the other one? If we see an exponent, basically, yeah. Just because there's a variable there, that's still an exponent. If you see a variable there, that is an exponent. Because if it was a 1, we wouldn't see anything there. So if there's a variable there, that counts as an exponent. Got all that? Everybody got that? Everybody got that? It's like, oh no. Write it down. This is, again, I'm still on the easy stuff. I saw you tuned out. You're in the zone over there. First I thought you were on your phone, but then I was like, nope, she just zoned out. If you don't see any exponents, meaning that everything really has a 1 there, that's a linear equation. So if you don't see any exponents, it's linear. If you do see an exponent, it just has to have 1, like every term doesn't have to have an exponent. If you see an exponent, it's going to be, could be a 2, could be a 3, could be a fraction. You see 1/2. You won't really see a decimal as an exponent. They put it in 1/2. If you see an exponent, it could be a negative exponent. If you see an exponent, that is now an exponential equation, or function, I should say. I keep saying equation, but equation and function are really the same thing for this lesson. Because we talked about how to determine if it was a function. In this lesson, everything we're just saying is a function. Okay. So again, we see an exponent. The exponent is a variable, but that's fine. If there's a variable there, that means there is some exponent there. So that means it's exponential. So the next step, and now we start to get into stuff that's a little bit harder, but not really. The harder part is you figuring these things out. What is the pattern? And I'm going to show you how to do that in a minute, where that's not even hard.
Is this stuff harder than the stuff you just like got over last week?
It can be. In all honesty, sometimes we don't do the hardest stuff. So just because we go through a lesson and you think, oh, that was really easy, that doesn't mean you're not going to see something on the FSA that isn't harder than what we've done. But we can't cover everything. It's just there's not enough. They gave us basically 2 days to do this whole entire lesson. And it gets, like I said, pretty complex. So we sometimes don't get to the super complex stuff. All right, so here's the next note you got to take. So in a linear equation, and we've kind of already done this, that's the slope we said, right? But the slope is the pattern. I'm going to get rid of, you guys have written this down, so I need more room.
So in a linear equation, the slope.
Slope is the pattern. So again, you should have written that equation down. If you want to do the same thing I'm doing, just circle the M, and then right above the M, like connect to the M, the slope is the pattern. Oh, I always forget the N. It's so weird. It's the third time I've just stopped at R. I don't know why. Mental block. Yep. That's what it said. Can see it. You should be able to see it. Huh. I saw Malik just hanging out in the mall today.
Bro, that didn't just tell me.
Just hanging out in the mall.
Oh.
For a while, he was hanging out in the mall because I walked through there
I
three
told him
times.
to go
He was
back to
there
class
every
late.
time.
What?
I heard. I think it was the assistant principal was telling him to go back.
Who was there?
If you go out there, like each period, you'll see the same people more than.
Oh, I have a little manual that I use.
Oh, okay.
Because yeah, that one.
Yeah, that one just
Crap.
heats it up.
And that one
I
died
just
on
went
me
to
over there.
Omar's.
I requested a pencil sharpener. I don't know if I ever heard back.
Miss Waiters? Yeah, Miss Waiters?
I don't remember who I requested from. Is it like, can you hang in for like 5 more minutes? I promise we'll be done in 5 minutes. So, in this is the y-intercept, first of all. So that's the y-intercept. This value is the y number when x is 0. So the b is going to be the y value or the y number whenever x is 0, which in most of this lesson, I think they're giving that to you. Now, sometimes you have to figure that out, and we will do some problems next time, and that's when it starts to get a little tougher. In today's lesson, you don't even have to figure it out. If you'll notice on the sheet, if you look at your sheet real quick that you picked up, every table has an x of 0. Like they don't make you figure out what the y would be when x is 0. They just give it to you, which makes this actually pretty easy.
What does that say?
Which part? Over here? Oh, so the b is the y-intercept, so that's the first thing. But it's also the y number when x is 0. So we're going to fill this out right now. So what's the pattern? We're doing the linear table because we're on a linear equation. What's the pattern? Well, it is, but what number? What are we adding?
5.
So yeah, so the pattern is 5. So again, I'll just write f of x there equals. So the pattern is 5, so I'll write 5. It's the slope. X is just x. We don't ever change x into anything unless we're solving or something. But when we're just creating an equation, we just have x in it. Should write that bigger for me. What's the b value? What is the y value when x is 0 in this table on the right?
5.
Yeah, it's just 5. X is 0 right here, so I just go to where x is 0. I just see what the y value is, right there. Now, I hate that I used the same number twice. I meant to change that. Just understand this 5, you need to draw an arrow or something. This 5 is that 5, and then this 5 here. Oh, actually, tell you what, I'm going to color coordinate them for you. I mean, you can do whatever you want, but just understand that 5 is that 5, and that 5 is that 5. We're going to do more examples, so you'll have different numbers, but I didn't even notice that I was doing that. So again, they just happen to be the same thing in this example. So that's the equation. It's only 2 pieces to it. I'm going to get rid of all of that because it's starting to get a little confusing. You're like 3rd or 4th in line. Poor Renai has been waiting forever. Renai has been waiting forever. What's that? Oh, you're right. I thought that was Renai. Was that you that asked for class? Right, so I may let you both. I may let all 3 of you. I'm not supposed to do that. I have held you forever. So.
I can take them.
Oh, that would work perfect. Yeah. Okay, so yeah, you guys can all go. I didn't think about that. Well, hold on, not yet.
Oh, not yet.
You gotta do one more thing. You gotta do one more thing. So I'm getting rid of all of that. Is everybody done with that? We're done. We're almost done. 1 minute. All right. It's recorded if you didn't get that. So now, I don't know why they did this. You have all this other stuff written down, even though I just didn't mean to erase all of it. In this formula, the A, for some reason, is the y-intercept. Why is it doing that? Okay, it's not letting me write. A is the y-intercept. It's still, though, the y value when x is 0. So that doesn't change. But it's confusing because we just had B was the y-intercept up here. Now A is the y-intercept. So just make sure you draw attention to that in your notes because it's the opposite of the linear equation. And then the B value is the pattern. So the B is the pattern. So in order to create this, the A value, what is, and we're on the left table, the exponential table, what is the value of A? What is the y value when x is 0? On the table on the left.
Wait, what?
Table on the left. What's the y value when x is 0? Table on the left.
0.
Nope, the y value when x is 0.
0.
5.
5. Crap.
X is 0. It's right there. When x is 0, what is y? All you do is that. Right what I just did. You draw a square, a rectangle, I guess technically, around where x is 0. Whatever the y value is in that rectangle, that's your A. So 5 is the y value when x is 0 times, what's the pattern? Just the number part.
0.
2 was the pattern.
2.
Times 2. We were multiplying times 2. 2 was the pattern. If you need to write the pattern as 2 when you go through and do that first step, do it. So that's the equation. X is just x. We don't change x, just like we didn't in the other equation. So now if you want to take those three, we're going to do some more of these when they come back. So that is the equation. 5 times 2 raised to the x power. So I'll let you guys finish writing that down, and then we'll do another example together, and then you'll start on the worksheet. You guys are going to be way ahead, I think, of the other. Everybody done with that? All right, so there's one thing. Remember, the pattern is always based on multiplication when you're talking about exponential. You always think, what am I multiplying times to get the next number? So I'm multiplying by 2 to get to the next number. Always based on multiplication. So we did, that's the same thing we just talked about. B is the pattern, A is the y value when x equals 0. I just did it all on the same screen. There is, no. So here, we'll use this. So again, the table is sideways. I want you to tell me, what is the pattern? I can't do that. Damn it. All right, never mind. Never mind. I had a table in there. Where's the other table? Did I not save it? Huh. Yeah. Maybe it's at the end. Oh. Dadgummit. All right, I have to draw it up real quick then. So here you go. Here's the table. So you're going to copy this table down. So as I write it, you have an X and a Y. X's are going to go 0, 1, 2, 3. Yeah, it's fine. So there, copy that table. Only went up to 3, so it shouldn't be fine.
You got it copied? You don't know. Hopefully you copied it. You got that copied. So copy that. Still a few people. And we're done.
All right. So now, what's my pattern? And the y values. Again, we don't really care about x's. They're going to go up by 1 pretty much every time.
5.
What's my pattern?
5.
Oh, I got one person saying 5. You may want to check that.
What happened?
Well, you're doing the right math, but what did I say the pattern has to be based on?
Oh, wait.
You never, here's your next thing you write down.
Oh.
Never look at the pattern and say the pattern is dividing by something.
Okay, I think that's common.
That will give you the wrong number, which means you'll get the
We would have
wrong
learned
equation.
division if we.
You've got to figure out, how do I determine what number I'm multiplying by? And I'm going to tell you.
It's a negative, that's why.
No.
It's a point, like it's a point something.
It is a decimal, not a negative. So here's how you do it. I'm going to give you really 3 steps, but it's really just 2 steps. I'm going to zoom out though so we can keep everything kind of on the same page. So when you have a table, and this works for the other table also, like it doesn't have to be numbers that are going down. The numbers could be going up and this will still work. And sometimes you need to do it this way because the pattern might be a decimal. Like you might be multiplying by a 1.25 or 1.5 or 2.5. So here's the steps to solve for the pattern. So actually you need to write all of this. So here, let me just, I'm not going to write it up because I don't have a ton of room. So you're going to write, to find the exponential pattern. This is only for exponentials that it works. You could do the same thing with linear, but it would be different math. So again, to find the exponential pattern. Write this down, all of you. Aaron, wake up. You aren't writing it either. To find the exponential pattern. Because the ones I've given you so far were pretty easy until we got to this one, and this one's actually not even that hard. They'll get harder than this. I think on the worksheet they're probably harder than this, but certainly on the FSA. But this will always work, what I'm about to do.
On the exponential pattern.
To find the exponential pattern, and we're just going to do it in steps. Thank you. So I'll come back up to the table in a second. Step 1. Step 1. You guys can copy this down when you have a seat. Start with the bottom y, and that symbol means number if you don't know what that means. So to find the exponential pattern, step 1, start with the bottom y number. And I'm going to have to kind of explain because there's no real easy way to write step 3. There. I'll go through all those, but you can write them down. Can't see them, I'll be saying them in a minute. So just hang tight. Actually, I guess I could zoom in real quick. And then I'll zoom out. There.
Oh
Step.
my God.
I'm going to zoom out in a minute, so.
That's the most zoomed in for us.
Actually, I think there's one more zoom. I just had it really zoomed out, actually, which I don't normally do. Because there's one that goes all the way across the screen. Actually, it's even bigger than the screen that you see.
I have a question.
Yep.
That's not related to math.
Then hold it. What class are you in?
Oh, no. Oh, math.
And there you have it. All right, so I'm going to kind of start talking about it, then we'll do the actual answer. So step 3, like when I say repeat by moving up the table, you're just going to do this same thing over and over again with different numbers, but it's still going to kind of follow the same like concept or logic or whatever you want. So now I'm going to zoom out. You're still writing again. I'm going to repeat. We're going to go through the steps so you'll see it. So I'm going to just use those two numbers first. So what's my bottom line number? What does that mean? Bottom line. Yeah, I go to the Y value, which is this column, right? The Y values are always on the right. You'll never see the Y values on the left. Y's are always on the right or on the bottom if the table is horizontal. So I go to the bottom Y number, which is 1.25. So this is step 1. So that's step 1. Right there, I just write down 1.25.
Also do the same thing over and over again. Why divide?
Yeah, just different numbers. Because you got to make sure there's the pattern's the same all the way up.
That's how you can explain 3 then.
Or that not.
I mean, that's the best I can come up with. If you guys, we'll talk about another way to do it. So now I would take that number and I would divide it by the number above it. Now that line means division. If you'd rather write it in your notes, you could do 1.25 divided by 2.5 like that. I'm going to write it the way I normally write division, the way you'll normally see it. So you take the 1 point, in a calculator, this is how you put that in though. That's why I wrote it that way in last one.
Is that 2.5 or
2.5, yeah. So I'm taking the bottom number divided by the number above it. And you get, what we already said, 0.5. You never say I'm dividing by 2. The pattern has to be based on multiplication, which is why we have to take this number divided by that to get what the answer is, which is 0.5. 1.5 divided by 2.5 is 0.5. So I'm multiplying by 0.5. So the pattern, and now I'm not done. I can't just do it once. Because remember, there may not be a pattern. If there's no pattern, then it's not linear or exponential. So I got to check to make sure I get 0.5 every single time. And that's what step 3 is. Repeat by moving up the table. So now that I've checked, Grace, real slow. I don't know why my board is so slow. So now that I've checked, and I just did the division there, 1.25 divided by 2.5. So I just got 0.5. Now I got to do that same thing everywhere on the table though. So I got to take 2.5 and divide that by the number above it, which is just 5. And I do get 0.5. Then I do the same thing here. Number here divided by the number above it. And I get 0.5 again, which means I got 0.5 every single time. So that is what I'm multiplying by every single time. So there is a pattern of multiplication by the same number every time. And that number is 0.5. if the numbers are going down, by the way, if you want to jot this in just as a quick note, if the numbers are going down, you have to be multiplying by a decimal or a fraction, whichever way you want to write it. That's the only way to get a lower number during multiplication, is to be multiplying by a number less than 1. Not multiplying by a negative. That doesn't do anything except change the sign.
If the numbers going down, do what?
If the numbers are going down, then you have to be multiplying by a decimal. Decimal or fraction, whichever one you want to write. Because think about it, anytime you multiply by a number greater than 1, it makes the number you started with bigger.
Are we doing this calculator for this one?
Yeah. All right, so I'm going to zoom out again, and we're going to actually do the formula, which is what you'll do in a minute. So if that's my table, and I've done this is the hardest part. Like once you do that, the rest of it should be easy, at least as long as they've given you the table that has all the values in it that you need. Oh, tell you what, I'm going to erase this part at the bottom. You should have all written that, the steps down. So again, my formula is what for an exponential? Is this, how do I tell if this is linear or exponential?
Adding or
Yes. Is it based on addition or is it based on multiplication? This is based on multiplication, so I know it's exponential. So what's the formula for an exponential function?
it makes one.
No, that's linear.
It's 8 times.
That's exponential formula. So I just need to find out what's my A and my B. A is what?
10.
What is it? How'd you get 10?
8 is 5. Ah! Wait, 5?
I don't know. What is it?
What's 5?
I don't know. Is it?
Yeah.
What is it? What's the definition of A? Look at your definition, or you should have written down what A stands for.
1.
1.
What?
0.
What in the world are you talking about?
X.
8.
Dude, we didn't write anything like that down.
Zero.
You need to look at your notes.
That's the slope. Wait, no, it's not. Wait. No, is it? Wait, hold on.
See what I mean?
it's the
You should have notes
y-intercept.
right in front of you.
That's
telling
the
me.
y-intercept. That's right.
So what is it?
It's 10.
0.
So what is it? Why is it
B
10?
is
Say
the
it again.
y-intercept. That's
It's the
zero.
y-intercept, but how do we know where the y-intercept is?
Because A
Zero.
is X and
Where
B
what is
Y.
0?
X.
When x is 0, here's what you do. You find x of 0, and you put a rectangle around it. That y value is your A. So if you put, again, I'd write that step in, because we struggled on that. And we just did one like it, and you got notes, but we still struggled. You need to give yourself more explanation of exactly what to do. So if my A, so here's where x is 0. When x is 0, y is 10, so that's 10. I'm going to use green. Hopefully you can see it. If not, I'll change it. Now, what is my b? How do I find the b value? What's your notes say about the b value? That's the pattern. What are we multiplying by? 0.5, right? That's the pattern, so I just write 0.5. And then my x is always just x, like that doesn't change. Just like when we did y equals mx plus b, we had y and x in the formula. Well, we're going to have x in this formula also, so I just leave the exponent as x. For now, I might do something with it in a minute and solve something out, but not right now. And then f of x would also just be f of x. That just comes down also. So you should now be able to do 21, 24.
Ooh, 22. What the
You should be able to do 25.
What is the heck is 22?
22 is the same thing, it's just fractions. We divide in fractions, which we'll get to that. We may do that one together. So right now, do 21, 24, and 25.
21, 24.
Yep. We'll start with, what is it?